So last time we did a little bit of a grab bag of Python features before we hit HTML. One thing that I forgot to cover that day is the idea of two-dimensional arrays. You know, a one-dimensional array is a list, but a two-dimensional array is a grid, a spreadsheet, right? So we have done this in the past, right? Where we made a list. But what if you had an array that looked like this? And firstly, I'm going to demonstrate that you can use the backslash as your to continue lines across the end of a character chart. And honestly, a lot of the times you can just not use the backslash as well, but the backslash always works as a way of extending this among multiple lines. Okay, so we have a list here and it's got the values 1, 2, 4, 6, and 10 in it for whatever reasons. What if your list looked like this instead? Just one more. There, you see what we got here? It's a list of lists. A list can be a member of a list as well as any other data piece. I mean, you could also have a list full of dictionaries, or you could have, dictionaries that point to lists or whatever. But it's a list of lists. The first list is that list. The second one is that. And the third one is that. And the fourth is that. So if you printed them out with our usual for value in list, print the value, we get 4 lists. Like that. Well, what if you want to address a specific value there? We want to change that 0 to a 9. Well, let's see. Which L element is it? Well, that's the element 0. That's the element 1. That's the element 2. That's the element 3. So L subscript 3. And then which one is it in there? Well, if I wanted to address it like that, I could do this, and this is not the correct way to do it. And then I could say, row subscript 0, 1, 2, 3. But there's no reason to indirectly reference it like that when I could just do this. L, and now I wish that this was in a different place so it wouldn't be 3, 3. So I'm going to change it so that that one is the one that's the 0. That's the one I want to change. Well, that's the third row. And what column is it in? Column 0, column 1. So now if I print it out again, I'm going to see that the 0 is gone and has been replaced by the 9. And as promised, the 0 has been replaced by 9. So every element in this data construct can be referred to by its X and Y coordinates or by its row and column coordinates. What if we wanted to remove 1 from every single element in here? Well, to do that, you wouldn't want to use a for value loop. You'd need to use range-based loops. So we're going to use for X in range and for Y in range, except I'm going to call the variables R and C for row and column. For row in range, well, okay, how many rows are there? There are 4 rows, and this is not the right way to do it, right? I should be asking the container for how many rows and columns there are. But we'll fix that in a minute. And then for column in range, how many columns are there? There are 5. And then we could say that the list element at row column minus equals 1. Remove 1 from that list element. All right, now it's silly to hard code those. I mean, yeah, you could, but what we really want to do is we want to ask the list how many rows there are. Well, that's just len, like we've done every other time, right? So the len of the list. There we go. I'm going to print a blank line here so that, no, well, that's not a print, is it? But I'm going to print a blank line here just because. All right. And the 5 will have to be fixed as well. Don't want magic numbers in there. Okay, but anyways, after this code ran through it, removed 1 from every row, 1 from every element in our 2-dimensional array. Well, what is L? L is the number of elements in the current list element. So list subscript row. See what's going on? Row starts off at 0. And then if we say L subscript 0, it's that. It cannot be. Excuse me. The length of that particular. Like that. Now, if you wanted to, you could use some kind of definitions like this. Num rows is equal to len L, and then num calls is equal to len of L subscript 0. And then you could write it, the same way. For row in range, num rows. And then for call in range, num calls. And then print out our list at that specific row and that specific column. If you like the way that looks, if it makes it easier to understand what the for loop's doing, go for it. This is quite correct. Works perfectly. Just whichever is easier for your brain to accept. This is more correct, though, than this is. If you are guaranteed that you have a perfectly rectangular set of lists here, meaning each one is of the same length, then this method works just great. Hey, come back here. And right now we do, so it will work great. Except for the fact that I have a quote there. This is not going to work, actually, by the way. For printing it out, what's it going to do? It's going to print all the numbers one after the other, not formatted as a matrix, right? Why is that? Because we're inserting a carriage return after each element we print. We print the 0, we go to the next line. We print the 1, we go to the next line. So we need to add the end parameter here. Well, okay, that was great. But we also need to add the carriage return after we're done printing out one of our rows. So, like that. And there we go, right? There's our two-dimensional array, our list of lists being stepped through with a doubling net with a nested loop, with a loop inside a loop. So as I mentioned, this works great when all of the lists in the row are the same length. But one of these could have been only too long, right? Then that kind of breaks, in my mind, the idea of a two-dimensional array. But since a two-dimensional array is a list of lists, this is perfectly valid syntax. I mean, even that's valid syntax, right? That's certainly going to crash. It's not going to work well at all when we get to that last for loop. The rest of it will work, right? List index out of range. So that's an argument for not doing it this way. Why is the list index out of range? Because we're using the first row to get our number of columns. Well, that won't work if they're not all of the same length. It's likely that they will be. So what if you needed 100 by 100, right? Not 5 by 4. Would I want to declare my array with 100 lines, it's all separated by backslashes and stuff? No, you would not want to. You want to declare an empty list, initialized to the size that you need. So I want something that is 10 rows of 10. There you go. You see what this is doing? Well, first, let's do this part. Let's remind ourselves of what this does. This just makes a list that is 10 long, where every single one of them is initialized with a value of 0. Like that, right? Create an array. I'm calling it an array. We know that Python uses lists, so this is the closest syntax to what other languages use as arrays, where you allocate in advance the length that you want, and then you just stick and put all your variables into it by replacing the elements, not appending or deleting them. But you could always do that. Now we have a 10 by 10 array. This is the number of rows, and that's the number of columns, right? In rows is equal to, we want 10 rows. In columns is equal to 7. We want 7 columns. In rows, come on, in calls, like that. Now, if you define your variables like that ahead of time, then feel free to use those inside any for loops where you need the number of rows and you need the number of columns. That's perfectly fine. So for row in num rows, for row in L2, print that row out. We'll see our 10 by 10 array right there. Here I just printed out the variable without any looping whatsoever. And we can see, you know, well, let's print out the original list in that syntax instead, which was just called L. So if I print L, here's our original list. And it is a list of lists, right? That's all a two-dimensional array is. Now I keep saying arrays. If you've taken a programming course that talked about arrays, the difference between an array and a list is that an array is fixed in length. It cannot be appended to, and items cannot be removed from it. Once you say, I want something that is 6 elements long, it's going to stay 6 elements long. You can't suddenly make it 5 or 4 or 3, and you can't start appending new. It's not dynamic. Lists are dynamic structures that shrink or grow as you append or remove data from them. Arrays are fixed in length. There are other differences as well, but that's the key operative difference between them. So we see that it's a list of lists like that. I'm going to print it out using this syntax instead. For row in L2, for row in the length of L2, for column in the length of L2 subscript row, print that specific element, L2 subscript row, subscript column, END is equal to a space. And then after we're done printing out every column in that row, we need to go to the next line. I did it again. For one thing, that should be a range statement right there. And so should that. Do I have the right number of parentheses? 1, 2, 1, 0. Yep. It's funny, it's how when it's printing to the screen, it's able to rip this one out a lot more quickly than that one. All right, anyways. So what can you do with a two-dimensional array? Well, anything you can do with a spreadsheet, right? These are just all data elements in a spreadsheet, effectively. You know, you have your columns and you have your rows of data. You can store whatever you want to in them. I can't think that if anything else has to be mentioned about that. How do you sum all of the elements of our list? We'd probably do so with a nested list. Excuse me, a nested loop. Total is equal to 0. And I could write it like that, but I'm going to go ahead and try to write it. So for value in the list, now this value is a array in and of itself, a list in and of itself. And then so for item in that value, total plus equals that item. That would do it. Or you could use this syntax, right? total is equal to 0 for, whoopsie, why am I? For row in range, the length of that list, the number of rows in that list, and then for column in range of the length of this specific row, then the total is plus equal to the list at that row, that's column. Except that's the total of L, not L2. L2 is all zeros, so that's why I didn't choose to do L2. And so there we go. This one supposedly adds up to 62. I don't see any reason to doubt that. All right, I can't think of anything else to do necessary to talk about. You can have lists that are embedded with lists that have lists in them. You know, you could do this. And that's silly, isn't it? But if we can try to unpack mentally what we're seeing here, this list is comprised of 4 elements, where the first one's a simple integer, the second one is as well, and the third one is a list of integers, and the fourth one is an integer followed by its own list. You can see that you could come up with 3-dimensional lists, 3-dimensional arrays, you know, 3 space, not just 2 space. And I guess the syntax for that would be something like this. We want to make a 10 by 10 by 10 array. We want like that there. That's a 10 by 10 by 10 array. Looks kind of silly. In other languages, you can allocate, for example, in Java, you could say, I want a list, not a list, I want an array that is a new array of ints, and I want it to be 10, 10, 10, like that. Something similar to that. Maybe a little bit more straightforward. In a C programming language, you would just say, okay, I want something that is 10 by 10 by 10. And then you're ready to use it. All right, I think that's about enough about 2-dimensional arrays. Or 3-dimensional arrays. Now, the 0 just means what value you're initializing it with, right? If I wanted to fill every number in my array with 999 instead, I'd put that in there. All righty. Enough about that. Let's go back to HTML.
One moment, I'm still kind of typing.
Sorry about that.
I'm almost done. Okay. So those last ones that we made are making an array and not a list.
Well, an array is a list. A list is an array. Python does not have arrays. Python has lists which we use as arrays. The difference being is that a list is a class, whereas an array is pure data. It's just a series of bytes allocated, one after the other. And languages like C++ and Java allow you to do that. In fact, that's what you're expected to do for that kind of thing. But they also provide classes which encapsulate access to memory like that in the form of lists. And Python did away with the idea of arrays entirely. And so they give you lists which you can choose to use as arrays. So in those languages, this would be considered an array use if you'd said, okay, I want 5 elements that are strings, right? Now I have an array of 5 strings. But what we have been playing with, at least at times, is to do this and then L dot append, some strings to it. This is a list style operation. Create an empty data structure and then start appending things to it. An array idea is to just go ahead and allocate it all in advance, and then it's going to stay of that same length no matter what.
Okay. So Python did away with the arrays because they're just less flexible than the
Right.
All right, got it.
So I'm going to get back into Windows because I like using TextPad. HTML elements, the tags are the elements enclosed in angle braces. The vast majority of tags require closing tags that match. The closing tags are the ones with the backslashes. So HTML/HTML, head/head, and they are nested like that. The tabbing is totally optional. Doesn't matter if you have it in there or not. So save as an HTML file. Your y.html. Let's put a paragraph of text in. Save it. Control S, launch it. This is a line of data. So HTML is just tokenizing this. It's treating each carriage return as a way of separating the prior piece of data from the next piece of data. And it's treating multiple carriage returns as though it were just one.
Well, is the P just for like a paragraph style, or?
That's correct. That's correct. That's how you break up groups of text. There are other ways. Why did I not save it? Yeah, there we go. Right. Now, if you want to embed carriage returns rather than use P to separate, each line of text, you can do so. Save it, then launch it. Like that. If you want your data organized in rows and columns, how timely, since we were just talking about arrays, you can use the table tag. Every table is comprised of rows. Each row has certain elements in it, like the number 100, the number 200, and the number 300. That's the end of our first row. That's somewhat tedious, isn't it? So I'm going to copy and paste that to make a second row. And make it say 200, 300, and 400. Whoops. I did not enclose that in its own new row. And strictly speaking, this is the body of the table, but it works just as well if you go ahead and leave out the body tag. But that is part of the specs of it, is that you put the data in that tag. So let's go and launch it now. And what will we see? We will see our data organized like that. That is some old school formatting that you can do with tables, including the border tag. When I say old school, I mean without the style attribute. Style attributes work just great, but if you do this, border is equal to 1. It didn't have a border before. And now it does, and you get this funky old school looking, presentation like that. That's like rocking at 1995. I'm sure that you've seen, tables on the internet if you've done some browsing, formatted like that rather than done in any prettier format. What if we wanted to format it prettier? Let's go look at table HTML formatting. Here's an example. Let me put this U3 schools. Okay, so anyways, and how was this done? Come on. HTML, head, they've declared a style for the table. The table's got a font, Arial, sans serif font. It's got border collapse set to collapse, whatever that does. I mean, I kind of have an idea, but I'm blowing past that. And then width, and then each row and each header, TH, stand for header, does have a border around it, 1px, solid. That's gray in hexadecimal. It's a shade of gray. Text align left, padding 8px. So we could play with that. This definitely is style information. So I could come in here and I could say, that really is the easiest way of doing it. I was going to do this, style equals, and then embed some of that stuff, like border colon 1px solid blue. But let's take a look at what that's going to do. Oh, I need to remove the old school attribute here if I'm going to play with formatting it like that. Now I don't see my border there that was specified there. So does that need to be specified on the individual elements instead? And I believe that may be the case. So I could go and put that there, and it's only going to apply for that first element, right? Because here's our tag, and that style applies for that specific tag. All right, that's not looking too great, right? So the style sheet, the cascading style sheet is the correct way of doing that. So let's go ahead and add that on. I'm going to undo that because we weren't having much joy there. And then I'm going to go and create a header section, which is where you put your style and your scripts. And so sneaking a peek at it, you put a style tag, and then you define the kind of element to which you are applying a style, and then in braces, you put the actual style information. So style, and I want to give style information for each one of these TDs, each one of these elements. So TD is going to have a border that's 1px solid blue. And it's not working. And I'm not getting an error message because, as I mentioned last time, in fact, it did at the same time, same reason. I did not close my style tag. So I shall do so now. Right. Think that'll work. Save it, launch it. And there it is. Now they had padding :0 in it to remove the spaces between the elements. So in their example, one of the things they did, or maybe that was border collapse. Probably was. Anyways, I'm not going to mess with that any further. But it is interesting how they did that. And nth child even. We're trying to make it so that some of them have white backgrounds and some of them have gray backgrounds. And I'm not going to figure out how they did that or what this is. I mean, I know that it works because we're looking at it right here. It's just interesting to me. Hmm. So if we look here, they've got a new element here that TH stands for header element. And so it just gives it a different appearance, right? So instead of TD, company, TD, TD, company, TD, TD, company, TD. And perhaps I should have formatted mine like that rather than putting it all on the same line, right? There. We talked about image. And then there's text formatting tags. This is more falls into that deprecated old school style where you put in information like that rather than, well, this isn't that bad. You can embed font specific information and colors, as I was trying to do, directly into the stream of the text. At least if you use EM for emphasis and strong for bold, then those are things that could be modified through the style attributes, right? So let's play with that. I'm going to come in here. So second line is really important and we want to emphasize it. Save that and then view it. So second line. And we may have decided that that needed to be even more purdy. And so we're going to say that all emphasized text needs to be red. So that will apply to the EM tag. So EM for italics. And then bold is done with strong. The anchor tag, the A, that's so that you can provide a link, a hypertext link, something that you can click on that'll go somewhere else. All right, so this thing that says here, I want this word here to be a link to Rose's website. It's not right now, obviously, right? It will be when we're done. So we're going to put this in an anchor tag. That's going to take a lot more than that. This is not our final answer. But if we do that, Then after we apply our information that is necessary, which is to supply the reference to where it's supposed to go, a space href equals, and then inside quotes goes the link to where we're trying to access, https://rose.edu. Save it and run it. Right now it's a link. That does in fact take us to Rose. So the A tag creates a hyperlink, which is used to link from one page to another. Each link will appear as follows. An unvisited link will be underlined in blue. A visited link will be underlined in purple, and an active link is underlined in red. So when we're looking at our lecture, this was originally blue, and then since I visited it and gone back, it's purple. And you're familiar with that. Nowadays everybody overrides those appearances so that all the links in your document no longer have lines under them. But that was the original HTML spec, and you are able to control how that looks via style information. If the A tag has no href attributes, only a placeholder. And then there are some other attributes: download, href language, media, rel, target, and type. The only one that I've ever seen used is that one. What are the attributes? Target. If you wanted to open a new page when clicked upon, you do target equals underscore blank. And that seems like an odd way of specifying it to me, but let's go ahead and do that. The order of the attributes does not matter. I could have put this after the href rather than before it, as long as it was before that final closing, that greater than sign. Save it, launch it. What are you doing? Was that necessary? All right. Now when I click it, it should open up a new page, right? My original page is still here, and I clicked on it and it went to Rose. I don't even know what the other ones do. I just know that one. You can use an image as a link by replacing this thing here with an image tag. So let's create a new hypertag reference. But instead of having any text, let's put an image. Yeah, I still have puppy PNG and things like that. So right there, going to be my image tag. Image source equals puppy.png. And I know that it's huge, right? So I'm going to make it smaller. Style equals quote, quote. The width of it's going to be 100 pixels. And if I don't specify a height, it scales proportionately. Save it. Load it. There's my dog. And following it went to the link. So tags can have attributes, specify their properties and behavior, the alt text for an image for screen readers. Some attributes can apply to every element: ID, style, class, and title. The ID is unique in the document. You should give everything a unique ID if you're going to refer to them by ID. Well, what's ID? Why would you bother wanting to give things unique IDs? ID is equal to table element 1. ID is equal to table element 2. ID is equal to table element 3. Now I'm wondering if I can do this. I'm not sure this is going to work, but if I go up to the style information, did I make those capital letters or lowercase? I don't recall. I made them capital. Can I say that T1, that text is supposed to be green? T2, that text is supposed to have a background color of yellow. Let's see what that does. Did not do it. Ah, you put a hash in front of it. Okay. Save it. And there we go, right? The first one has green text and then a yellow background. I think I want to add that border collapse thing that we saw in that other one to see if it makes all that those go away. So where was that? So for my table, border collapse, colon collapse. Let's see if we can get that going. So where's my table tag? Right here. Style equals border collapse, colon collapse. Save it. Launch it. And there, right? No spaces between our lines. Much prettier. We will be hitting this idea pretty strongly again in the near future when we actually start embedding JavaScript in it. Because, well, what's happening? When we run this, our browser asks for this text file, the server gives it to us, and then the browser has to figure out what to do with it. And so the browser constructs a model in its mind of what's coming in. It's called the document object model. And it's actually arranged in a tree-like structure in its mind, but you have one HTML page, and in that HTML page, there is a list of items in it, and each list of items can have sublists of items in it, right? Kind of like our two-dimensional arrays in Python. And then once it has completed that document object model in its mind, then it turns it into a graphical representation so that we can see. It creates the pictures on the screen that we can click in. And if anything modifies that document object model, like changes the color of a piece of text or whatever, then the browser go ahead and obligingly follows along with that. And so with the document object model, JavaScripting is a way to interact with that, to give web pages interactivity. Because before JavaScript, about the most interactivity you had with web pages is that you could have lists of things that you could click on, and you could have a data entry field where you could type in some text and then click a submit button. That was pretty much it. None of this cool rolling your mouse over and having things light up and drop down lists and things being responding to your mouse motions and stuff like that. Pretty much all you had was the ability to choose items from a list and then click on links, right? Or to type in some information into a form and click a submit button. That was it. JavaScript gave the web developers the ability to make the elements of the web page interactive, so that if you click on something, something happens. And then when that something is happening, new data elements can be inserted into that internal map so that more things will be displayed, or their values can be changed, or pieces can be removed. And where did the name JavaScript come from? Well, at the 90s, when this was first being introduced, Netscape, by the way, were the people who invented JavaScript. They called it JavaScript because Java was the hot thing. Java was the hot programming language. And so they thought, well, if we call this JavaScript, it'll get way more attention than if we had called it something like NetScript or DOMScript or something like that. It was just pure marketing to choose the word Java as part of the name of it. It has absolutely nothing to do with the Java programming language. They share elements in common, but all programming languages share elements in common, right? Heading, subheading, paragraph tags, div, and span. A division, it's kind of like a paragraph. It marks off a new block on a screen, whereas span applies only to a certain sub part of a paragraph. So if I wanted to colorize a certain section of text on my screen, I could do that. So this right here, span style equals quote background dash color colon yellow semicolon end quote in parentheses line of, and that's the end of that span. So we are modifying the appearance for that specific little subset of data in our paragraph. Like that. And like I said, this is an extremely long document. I'm not going to go through every single tag. HTML is about structure, not appearance. The style attributes are what controls the appearance. The HTML creates the data structure. Browsers tolerate invalid HTML code and parse errors. They try to, at least. You should not. That just means that we should try to write our HTML code as correctly as possible. You can rely upon things like the fact that if you leave off a closing tag quite often, the browsers are forgiving. What do I mean by that? If I did this, this is going to create a table with one row and two items in that row. And it's actually going to work. It's not going to crash. We're missing closing tags, but the browsers try to handle poorly written HTML. And so there's our new table down there, right? Didn't crash, didn't generate any errors, but you saw up here that when I forgot to close my style tag, we didn't get anything at all. So obviously it's not perfect. How could it be, right? So we do want to try to use good syntax. We do want to try to keep our syntax correct. HTML documents must start with a document type definition, tells what browsers the type the served code is. Possible versions, HTML4, HTML5. Here's an example, a doc type. All right, yeah, I could copy this and paste this in there. And if I was a web page developer and I wanted to produce professional code, I would do that. This is one of those things that if you leave it out, it still continues to work. XHTML is more strict than HTML. All tags and attribute names must be in lowercase. All tags must be closed or self-closing. I mentioned that last time. Self-closing tags are the ones that you don't need a close image tag. So when you create your image, you should just put a backslash at the end of it to mark that that tag has closed itself. HTML allows self-closing tags to just go ahead and self-close them, and it tries to imply missing close tags. XHTML allows only one root HTML element. HTML allows more than one. I've never heard of coming in and adding a separate HTML block. I do not even know what that would do. Save it, run it. Okay, what do you know? You can have two bodies to your HTML document. I've never have seen that. I'm going to delete that. That is so bizarre. Not legal under XHTML. Many element attributes are deprecated in XHTML. Most are moved to CSS. Attribute minimization is forbidden. I'm going to skip some of this. The script tag. Now we're talking. What's going on here? Up in our header, we have defined a block of script called say, and in it, we have declared a function called say hello. And then down here in the body, we invoked the say hello function. I'm going to make a new one, call it lecture y2.html. Okay, so up here in the head, we want to put some trying to get it so I can see the PowerPoint and the text editor on the screen at the same time. Okay, so script type equals text / JavaScript. Now we're going to write a function. No DEF keyword. Instead, use the word function. And rather than colons and tabs, we use curly braces. And what are we going to do? We're going to document write. Now, let's write a second line. And now down here in the body of our code, we want to call this function. So script type equals text JavaScript, and then call the hello function. I'm going to do that slightly differently. What onClick does is it specifies a function to be called when that object is clicked. So yeah, let's give it a shot with that button tag. So down here in the body, I don't want to do it with that. Instead, I'm going to do it so that it's slightly interactive. Slow inside our body. I'm not sure this is going to work. Let's find out. Button on click equals quote, and we're going to call the hello function. Is it doing anything? I don't know. What document write does is it just appends these pieces of information to the document object model. Since that didn't work, I'm going to go ahead and try the script type equals. Well, here I called it test. That was dumb. Text, how about that? And then let's call the hello function and then close our script. See if that works better. If you want to comment something out in HTML, you do it like that. That opens the comment and that closes the comment. Angle, exclamation mark, dash, dash opens a comment, and dash, dash greater than closes the comment. So now that button is not actually in the HTML. All right, so what happened? Loaded up. As the body loaded, it called the script. The script did some document writes, which added this stuff to our document object model, added us a header and a paragraph. We are now already in the domain of programmatically generated code, right? What if we used a for loop to spit paragraphs out? You declare your variable, And then for I is equal to starting value, I is less than a value, I plus plus, and then inside curly braces, you have what you want it to do. Let's go do that. So function para. Paras like paragraphs. So variable I, and then for I equals 0, semicolon, I is less than 10, semicolon, I plus plus, close parentheses, open curly brace, close curly brace. And I'm going to move this document right up there. And then instead of calling document right there, I'm going to call paras like that. And now we get 10 paragraphs of text. What if we wanted that to be controlled by a value passed in? What if we wanted an argument? Well, let's create a variable that'll accept that argument. So there's our parameter variable. And we're going to keep saying, keep going while I is less than lines. That worked. And so if I change that to 100, now we have 100 lines of text. Their example over here for the on-click event, which is when I was trying to make the button active to something, they have their button calling something called my function. And my function is written like this. Get our element by ID and then change its inner HTML. So when we click on click me, it changes our inner HTML to say hello world. Well, what's our inner HTML? Element by ID. We have a paragraph of text here with nothing in it. We need to give it a unique ID. P1. I'm going to uncomment this out, and I'm curious now how these paragraphs and these headers will work along with having this button and this line of text here. Yep. So there's the call to the function generated the top part of the web page. And then we have our button. This will be the last thing we do. And then some text. So when the button is called, it needs to call a function. It's not going to call hello, though. My function. Their name was pretty cool. Let's go with that. All right. And so up here inside my scripts, function, my function. Document get element by ID tells it to go and search the document object model, finding the specific node that matches that ID. I'm going to break this into 2 steps and not 1. I'm going to do that. Node is equal to document.get element by ID, but our ID was called P1, I believe. And then we're going to change his text. So when the button is clicked, it should call my function. My function should search the document model for the ID matching that. And then we will change the inner contents of it to no longer say I will change, but I have changed. And so let's right click and do view page source. Yep, looks just like what we had. How about if we right click and do inspect? If you do inspect, you get an idea of the document object model. I know this is really small on your screen, but you see that there's an HTML tag, and then there's a head tag, and there's a closed head tag, and then there's a body. And the body has 100 paragraphs in it. And then down after the paragraph, there is a button. And then there's a paragraph of text that says, I have changed, right? Now, that's not our source code. Our source code had it say, you know, I will change. The model is the current state of it. And so the text actually has changed at that point. And if I wanted to, I could do, you know, things like I could edit the internal HTML, or I could hide that element, or I could delete it, or whatever. You know, I could interact with the document object model directly via that inspect mechanism. All right. So one of the takeaways, this programming language's syntax is distinctly different from Python, right? But the same concepts are there. You can define functions. You can have parameter variables. You use curly braces rather than colons to denote your blocks of code. And this is actually far more standard among programming languages than using colons and indentation. Indentation is optional. You don't have to do it. You do have to declare your variable before you begin to use it. I do think that we could have probably have declared it right there and have it still work. Yeah, but you do have to declare your variable before you can use it. I'm going to undo that because I kind of liked the way that it looked. Notice that you're not giving it a type, though. Languages like C, C#, and JavaScript, the more strictly typed languages, you would not only say this is a variable, but that it is an integer. JavaScript, you just have to say, okay, it's a variable, and I don't care what kind of variable it is. It just creates a spot in memory for it, and then later on, you can assign any kind of data that you want into it. The for loop syntax is different. This is a very common for loop syntax. It's based on the C syntax, the C programming syntax, where you have your initializing state, you have your comparison, and then you have your update. Could have been written as a while loop as well, right? Variable k is equal to 5, semicolon, while k is greater than or equal to 0. Document.write, parentheses, quote, parentheses p, end parentheses, quote, plus k. I really don't know if this is going to work. Plus closing our tag. And then subtract 1 from k. K equals k minus 1. And then let's write out one more thing just to validate that portion worked. So I'm expecting this to say 5, 4, 3, 2, 1, 0, right? because we're starting K off at 5. I'm not sure if that's going to convert to string or if I need to have a function that'll turn a number to a string. Let's find out. Yep, and there it goes, right? 5, 4, 3, 2, 1, 0, all done. So yes, the syntax is different, but it's not incomprehensible. You already know enough about programming now that you could just look up JavaScript syntax for it. What does a JavaScript for loop look like, right? What does a JavaScript while look like? If I did need to convert a number to a string, and if that hadn't worked, JavaScript convert integer to string. Aha, and there's a function called toString. My guess is that well, I'm not seeing it. It's variable name followed by .toString. This will be the very last change I make it to it. So k dot toString, like that. And toString is a function that was added to the integer class, just like underscore underscore str underscore underscore is in the Java classes. Make sure that works so I haven't been proved a great big liar, and then we'll close for today. Yep, worked. All righty. So when we get back, we're going to be done having talked about HTML itself pretty much. We've already seen all the elements of HTML enough to go by, right? Instead, it'll be JavaScript specific. So we will do more based on JavaScript. And then on the lecture after that, on Thursday, we're going to do what's known as server-side programming, where Python is used to generate the web page rather than using Python on a client. Python is actually going to be my web server, and I'm going to open my browser, and I'm going to go to a specific address and then access, let Python be serving up my web pages, and everything that we see is going to be generated programmatically rather than as a text file that we edit in TextPad and save to the file, save to disk. All right, so are there any questions while I'm off to create the Dropbox? Also two-dimensional arrays.